In this video, you will learn how to solve systems of linear equations by elimination. To eliminate means to get rid of or to remove. When equations in a linear system have a pair of like terms with the same or opposite coefficients, you can subtract the equations to eliminate one of the variables. Then use the equation you're left with to solve the system. A coefficient is the number in front of the variable. Example number 1, 2x plus y equals 3 and negative 2x plus 5y equals negative 9. We are looking for one of the variables to have a coefficient that is the same or opposite. Take a look at the x terms in these two equations. The coefficients in front of the x's are 2 and negative 2. They're opposite. So we can take these two equations and stack them up and add them together in order to eliminate the x variables. Let's take a look. Here I've spread out the equations a little bit so that you can line everything up. We want to line up the x's and the y's and the equal sign and line up the number at the end. So we have 2x and negative 2x. When we add these two together, we have eliminated them because 2x plus negative 2x is 0. So let's add together what's left of the two equations. So we have the 2x and negative 2x is 0, and then 1y plus 5y equals 6y, and 3 plus negative 9 equals negative 6. Now we can just continue on and solve for y. Divide both sides by 6, and we get y equals negative 1. Now we've solved for our first variable. Our next step is to figure out what the other variable is. In this case, we already know y. We need to figure out x. So let's take one of the two original equations. It doesn't really matter which one you start with, as long as you use the other one later to check. So let's take 2x plus y equals 3. And now since we know that y is negative 1, we can substitute negative 1 in for y in this equation. So now we have 2x plus negative 1 equals 3. Then we can change that. Let's get rid of the parentheses so it looks a little bit cleaner. Add 1 to both sides in order to isolate the x term. And then we have 2x equals 4. To solve that, we need to divide both sides by 2, and we end up with x equals 2. So now we have our other variable also. We know y is negative 1 and x is 2. But we need to check to make sure that the solution works in both equations, not just the one that we used to solve for x. So let's use the other one, negative 2x plus 5y equals negative 9. And this time we can substitute both our x value and y value in and see if our equation works out to be true. So in place of x, we'll put 2, and in place of y, we'll put negative 1. Negative 2 times 2 is negative 4, and 5 times negative 1 is negative 5. So when we add together negative 4 and negative 5, we get negative 9, which makes this equation true. Negative 9 equals negative 9. So yes, we have the correct solution. Example number 2, 5x plus y equals 2, and 5x minus 3y equals 14. This time, you might notice that we have two x terms with 5 as a coefficient, but we need them to be opposite, like a positive 5 and a negative 5, in order to add them together and eliminate. So our first thing we need to do in this problem is that we need to choose one of the equations and multiply the whole equation by negative 1. That's going to change the sign of every term in the equation. Let's multiply the second equation by negative 1. There's no rhyme or reason to why I chose the second equation. Either one could be chosen. Negative 1 times 5x is negative 5x. And then the negative 1 changes the negative 3y to a positive or plus 3y. And then the negative 1 changes the 14 to a negative 14. Now we have the ability to eliminate the x terms because one is positive 5x and one is negative 5x. Now let's stack up our equations, including the new equation that we multiplied by -1. 5x plus y equals 2, and -5x plus 3y equals -14. We can eliminate the 5x and the -5x. That was our whole goal. That was the reason why we multiplied the second equation by -1. Then we end up having y equals 2 and 3y equals -14. Y and 3y is 4y, and then 2 and -14 is -12. Then we can solve that by dividing both sides by 4, and we end up with y equals -3. So we have solved for y, and now we just need to solve for x. Now let's use the y value that we found to find value for x. 5x plus y equals 2 is the equation that I chose to start with. So 5x plus -3 equals 2. We can clean it up and get rid of the parentheses. We don't really have to have those. It helps us keep track of the signs. Then we can add 3 to both sides to get the x term by itself. We have 5x equals 5. And if we divide both sides by 5, we end up with x equals 1. So now we have our x value and our y value. Now we need to check and see if we plug those into the second equation, if it is a true statement. Remember, when we check, we need to use the other equation that we didn't use the first time. So I'm going to use the original second equation. 5x minus 3y equals 14. Notice I used the one before I changed all the signs by multiplying it by -1. It's okay if you use the one that you multiply by -1, but I like to go back and use the actual original equation. So when we replace the x and y with their values, we have 5 times 1 minus 3 times -3 equals 14. That gives us 5 plus 9, because -3 times -3 is 9, positive, equals 14. And 5 plus 9 on the left side equals 14, and we end up with a true statement, 14 equals 14. That means our solution 1, -3 is correct. In the last two examples, I'm going to show you how to get started because they're a little bit more complicated to start with. But then after that, they work the same exact way as the other ones. So I'll get you started on them, and then I'll have you try it, and then you can check back with the video and see if you got it correct. Example number 3 is 2x plus 3y equals 7, and 3x plus 4y equals 10. You might have noticed that neither of the terms with x's or the terms with y's have a coefficient that is the same number. So the x's have a 2 and a 3, and the y's have a 3 and a 4. So that means we can't just start subtracting and eliminate. We're going to have to change up these equations before we can eliminate. That's why I told you these start a little bit differently. So to start with, let's try to make our x terms have the same coefficient, one of them being positive and one of them being negative. What we can do is multiply both of these equations, just like we did in the past when we multiplied by -1, but we can multiply the top equation by 3 and the bottom equation by 2, and that will get us 6x for both of the x terms. In this case, though, we're going to change one of those to be negative so that we get a positive and a negative x term so that we can eliminate them. So let's do 3 times 2x plus 3y equals 7, and -2 times 3x plus 4y equals 10. That's going to look like the distributive property that we learned in the past. We have to make sure that we distribute it to every single term, including the number on the other side of the equal sign. So the equation on the left is going to be 6x plus 9y equals 21. And the equation on the right is going to be -6x plus -8y, or -8y, either way is the same, equals -20. Let's take those equations and look at them a little bit more closely next to each other. And then we can go ahead and eliminate the x terms, and we end up with 1y equals +1. So y equals 1. Now go ahead and finish up the rest of this problem and find x and then check. Compare this to how you did. Did you end up getting 2, 1 also? If not, take a look and see why. Where did you go wrong? What mistake did you make? And how can you make sure that you don't make that same mistake next time you do a problem like this? Example number 4. We have 3x equals 5y minus 9 and 2y equals 3x plus 3. Something that's really important when you try to eliminate one of the terms, one of the variables, is that you have everything lined up the same. So here, if we line up our equal signs, we can see that the two y terms and the two x terms are not in the same spots. So on the left of the equal sign in both equations, we have a 3x for one of them and a 2y for the other. Since they're not both x's or both y's, we're going to have to move some things around to make sure that we have everything set up correctly before we can eliminate. So I'm going to take the second equation and I'm going to move things around and solve for the x term, basically. We want to get the x term on one side of the equal sign by itself, just like the first equation. So 2y equals 3x plus 3. Right now, the 3x is on the right side of the equal sign, but we need to switch it around and get it to the left side. So let's subtract 3x from both sides of the equation, giving us 2y minus 3 on the left and just 3 on the right. But now we have that 2y term over on the left that we need to get rid of. So let's subtract 2y from both sides, and we end up with negative 3x on the left and negative 2y plus 3 on the right. Now this equation is exactly the same. It's equivalent to that original second equation, 2y equals 3x plus 3. Once we move things around, as long as we did our math correctly, those are equivalent equations. And that new equivalent equation is set up the same as the first equation. Remember, that was our original goal, was to get both equations set up in the same way so that we can eliminate one of the variables. So let's take that new equation and put it right underneath the first equation. And now we can see that we have a positive 3x and a negative 3x. So now we can go ahead and add those two equations together and eliminate our x terms. Let's go ahead and walk through the first couple steps here because this one is a little bit interesting as we get started. So we'll eliminate the two 3x terms, the 3x and the negative 3x, when we add them together, so they are gone. And the interesting thing here is that is a 0, and that's the only thing on the left side of the equation. So right now we need to put a 0 there. Then we'll combine 5y and negative 2y on the right, and we get 3y, and negative 9 and positive 3, and then we get negative 6. Now, just because this has a 0 on one side of the equal sign doesn't mean it's really any different from any other equations that you solved in the past. So we can add 6 to both sides of this equation to get the y term and the constant term away from each other. So add 6 to both sides and we end up with 6 equals 3y. And I think you can pick it up from there. So go ahead and pause the video once you've gotten to that point of 6 equals 3y, and then come back and check and see how you did after you solve for y, solve for x, and then check your work. All right, are you ready to compare your work to the example? So we ended up with 1/3 2 as our solution. Go ahead and pause this on the screen so that you can compare your work to what we have here on the screen and see how you did. If you did not get 1/3 2, you need to make sure that you carefully look and see what you did incorrectly so that you can figure that out and get it right next time. Now you should know how to solve systems of linear equations by elimination. Thanks for watching.